Welcome to another edition of Math for No Reason. In this edition, we look at this particular problem. Here we have a function f whose domain is the closed interval 0, 1 and the range is also the closed interval 0, 1 and f is a continuous function. We also know that f0 is not equal to 0 and f1 is not equal to 1. We have to show that there is a point C which lies between 0 and 1 such that fc is equal to c. Now, note that we can think of a continuous function as one which can be drawn without lifting the pencil. We can look at this graph. So, this curve is f. F of 0 is a number which is greater than 0 but less than 1. Similarly, f of 1 is greater than 0 and less than 1. And f is a continuous function, so it can be drawn without lifting the pencil. And no matter what such functions we draw, we note that this graph intersects the line y is equal to x. So, this line is y is equal to x. And this point we can think of as C. For the orange curve, this is the point C. So, at this point, f of c is equal to c. Similarly, here again, f of c dash, say, is equal to c dash. So, this appears to hold for any function that obeys this property, and we will try to prove this in general. Now, to prove this in general, we will consider a function hx, which is fx minus x. Since f is continuous and x is also continuous, so h is continuous on 0, 1. So, f0 is not equal to 0, so f0 is greater than 0 and h1 is f1 minus 1 and f1 is not equal to 1, so f1 is less than 1, so f1 minus 1 is less than 0. So, h0 is greater than 0 and h1 is less than 0. So, h must have a root in the open interval 0 to 1. This is often referred to as a Bolzano's theorem. If a function is of one sign at the point A and is of another sign at the point B, then in between these 2 points there is a root. So, this result is referred to as the Bolzano's theorem. A more general version of this Bolzano's theorem is known as the intermediate value theorem. So, h of some c is equal to 0 where c lies between 0 and 1. So, c is the root and therefore, fc minus c is equal to 0, which proves our claim that fc is equal to c. That's a good point to stop. Thank you.